Hello there, honors geometry students. Welcome back. In this video, what we are going to be talking about are parallel and perpendicular lines. So our goal of this lesson is to be able to relate slope to determine an existing relationship between lines, as well as construct lines that must be parallel and perpendicular. Okay, so we're not going to approximate here. We're going to be pretty precise. So before we get into this, let's think about some of the background things that we know, right? So we've done some work recently. We've talked about slope a lot. You talked about it a bit. I like this arrow. In previous courses as well, right? But one of the things that we talked about in class today is how you find slope, right? So maybe you remember rise over run, right? So how much are you going up and down over how much are you going left and right? Right? Or that is the same thing as the change of y over the change of x, right? That's what delta is, delta y over delta x. And then you also had a formula that's y2 minus y1, so the difference of the y values over the difference of the x values, right? And this would be given a point x1, y1, x2, y2, right? So any 2 points on a line. There's an infinite number of points on a line. We've also talked about different ways to write the equation of a line. And there are 3 forms of a line, right? So you've got point slope. We did this first semester too. You've got slope intercept. And then you've got standard. I'm just going to, right off the bat, just cross off standard because we're not going to worry about this. Okay, standard's not one that we're going to focus on, and it's not one that is super commonly used. So if you know it, cool. If you want to look it up, awesome. But we're not going to really be talking about it because it's not really something that comes up often and is super helpful to us as we move forward. So point slope, like it's in its name, right? Oh, I have a point and I have the slope, right? I have an x1, y1, and I have the slope. I have m. Okay, and that's what this is. And so it can be written a few different ways. You could write y equals to m times x minus x1 plus y1. Okay, so I'm going to highlight the things that you know. That's not a highlighter. So m would be our slope. Okay, our point that we know, and this could be any point, maybe I know more than one, is going to be this x1, y1. Okay, and everything else is going to, like, this y equals, something's going to go here, parentheses, x, right? And so, like, oh, x is left and right. You can think of them almost as a shift, like how much right and left is it moving? How much up and down is it moving? Okay? Slope intercept is also pretty literal. I have the slope and I have the y-intercept, right? So I have a point 0, y is what it would be, and that is represented by the letter b. So this looks like y equals mx plus b. Right, so, okay, slope is going to go right here. Y-intercept is going to go right here. I'm going to back up. I said this could be written 2 ways. Sometimes you see it as y minus y1 equals to m times x minus x1. Sorry. And these are also on your formula sheet, right? So, like, use it. Keep using that formula sheet, right? These are the same, right? I'm just basically saying, oh, let's subtract y1 from both sides. I want to emphasize that, like, let's try to use this one or this one, right? Like, we want point slope is my favorite. It helps us a lot more. We don't need, like, if we could have any point, this one we need a specific point, right? You might be more accustomed to y equals mx plus b. This other form is nice to us because we don't need it to look like this, right? I don't need to have a specific point. I can have any point. That's the best, okay? So I wanted to talk about that really quickly. And then I also want to go back to these words parallel and perpendicular. What does parallel mean? I'm sure you're yelling at the computer right now and saying parallel means that it's 2 lines or more that never intersect. We did a whole unit talking about the parallel lines, right? They never cross each other. Hopefully you remember it could look like this, right? I could write AB is parallel to CD, right? There's my notation. What's perpendicular? I feel like we keep talking about this. Oh, perpendicular is that it forms a right angle where they intersect, which is 90 degrees. We're not going to assume, we're going to actually know that it forms 90 degrees. Okay, so that symbol, right? Like maybe I'm saying AB is perpendicular to CD. So just recognizing that notation and using that notation, right? And so I would have to know something like this. Maybe it's marked off that way, or it says 90 degrees. Okay, so let's get started with how we can kind of combine these concepts and work through this. So let's investigate. Let's graph each of the equations below on the graph below. Okay, and so maybe you have this printed out, maybe not, and you're just doing it on scratch paper. That's fine too, but I would say maybe pause the video and try it. So these are both given to us in the form of slope-intercept, right? Y equals mx plus b. So let's start with line A, and I'll go ahead and see that the slope is -4/3, right? So my line's going to decrease. That's a good thing to go into it knowing, and my y-intercept is 1. So when I graph this, I'm going to start with that point 1. Okay, I'm going to graph this one in red. And then -4/3. So I'm going to go down 4, 1, 2, 3, forward over 1, 2, 3. Right, there's my second point. I don't need any more points unless I struggle to graph it. But 2 points to find a line. There you go. So there's my first line. Let's graph our second line. For our second line, this is our y-intercept. This is our slope. Okay, so I'm going to go ahead and graph this in blue. So I'm going to start at that point 4, right? Think about it, if I plugged in 0, 0 times anything is 0 plus 4 is 4. So I get the point 0, 4. That's why that's a point on my graph, right? Just a nice one that works out. And then 1, 2, 3, 4, 1, 2, 3. Oh, I missed the point. Huh. Oh, goodness. It's okay. Okay. So I missed the point a little bit. We'll pretend that didn't happen. Maybe you're looking at this and you already know what my next question is going to be. Right? Like what is the relationship between these? What do you notice about the two lines you graphed? Right? It might be obvious because we just talked about it, but let's look at like the distance between any of these. Right? Like 1, 2, 3. 1, 2, 3. 1, 2, 3 approximately, right? It's not exact, but 1, 2, 3. My graph isn't great. Right? So, or even better, if I actually found this distance and this distance, right? Like what's happening? These lines are always the same distance apart, right? They will never intersect. They are increasing or decreasing at the same rate, the same rate of change. Oh, maybe you know where I'm going with this, right? So these lines, line A and B, are parallel. We're doing some assumption, right? It might feel like we are, but there's actually a reason that I can confidently say that they're parallel. And I could go ahead and put these markings on them. I'm not assuming anything, right? How could we have determined that the lines are parallel before we even graphed them? They grow, they increase or decrease at the same rate. Increase or decrease at the same rate. Rate of change. Isn't that just slope? These lines have the same slope, right? Right away, the slopes are the same. Any two lines that have the same slope are going to be parallel, right? It's a key point. So I want you to keep that in mind. Maybe you already knew that. Maybe you remember that from first semester or from Algebra 1, or you're just like, well, duh, I know that. Maybe not, and it's new. Either way, we're all getting this now, right? So like lines that have the same slope are parallel. So I want to identify M. Okay. Well, what about these two lines? These two are not parallel. We might make an assumption, right? Like maybe I'm going to assume that they're perpendicular. Can I assume that? Do I know that they're perpendicular? Is there a way for me to find it out? And I guess, right? I guess I could do the Pythagorean theorem here. Something with that and see, are they actually perpendicular? It's a little difficult to do, right? I don't know how to count all of this. I could, but I don't actually know these lengths, right? So that would be a little hard. That would actually be a pretty cool way to prove it if we were doing some real discovery. But I'll keep that in mind for next year. So let's start. Let's see. We're gonna hold in our mind that we think that these might be perpendicular. We think that this might be 90 degrees. Okay. Let's see. Let's write down the equation of line A. This one over here. So I have these 2 points. I'm just gonna pick one. I'm just gonna pick this one. Y equals to, what's the slope? 1, 2, 3, 4, 1, 2, 3. -4/3. I don't have the y-intercept. I don't know what this point is. Let's not guess. Let's use our other formula. X minus -1 plus 2. Well, we know this, right? So y equals -4/3 x plus 1 plus 2. This is a perfectly great equation. If you really, 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 really wanted it in slope-intercept form, I could get it in that, right? I could distribute the -4/3. This is a good math practice. And add 2. And I would get y equals -4/3 x. When you add 2 here, you can use your calculator, or you can think through -4/3 plus 2 is the same thing as 6/3. It'd be plus 2/3. Right? This is the same equation. I can go into Desmos and graph it right now, and I would see that they're the same. Okay, so we got A. Now, let's go ahead and write the equation of B. So again, I don't know what the y-intercept is. I'm just going to go ahead and use this point. It doesn't matter. I'm just going to use, oh, whoa, that's not 0, -2. That's definitely -1, -2. That's not 2, -2. That's 2, that's 1, -2. Oh, no, and this is -2, too. Whoops, I might need to back up. Well, that was a good practice, but I made a mistake. Right? I labeled the points wrong on this. Goodness gracious. Okay, redo. Okay, real life mistakes. Let's see now. I think I counted it correct, right? I think my slope is still -4/3, but I want to use this as my point. So it would be x minus -2 plus 2. So y equals -4/3 x plus 2 plus 2, which is a great equation. Let's redo this. I could distribute the -4/3 if I wanted, right? That would be -8/3 plus 2. I could use a calculator, or I could think -8/3 plus 6/3 is going to be negative, right? -8 plus 6 gives me -2, right? And so this is a good skill. Like you definitely want this as you're thinking forward to Algebra 2 and SAT and moving forward in general. But you don't need to write it in this form right now, okay? So let's do the same thing for the equation of line B. So I'm gonna pick this. It's not 4-1, it's 3-1. And my slope up 1, 2, 3, and over 1, 2, 3, 4. So y equals 3/4 x minus 3 plus 1. Right? There's my equation. If I want to write it in a slope intercept form and find the y-intercept, I can distribute the 3/4 minus 9/4 plus 1. -9/4 plus 1. I could write 1 as 4/4, right? I want that common denominator. And then I would have 3/4 x minus 5/4 if I wanted to figure that piece of it out. Okay? So, what is going on with these equations? If I take a closer look, I looked at the slope before, so let's do that again. Negative 4/3 and 3/4. Negative 4/3 and 3/4. Negative 4/3 and 3/4. Sorry, I didn't like that highlighter. Negative 4/3 and 3/4. Okay, so one's negative and one's positive. That's good to know. And then what did I do with the fraction? I flipped it. I flipped and negated it. Huh. So when the slopes are flipped and negated, the lines must be perpendicular. Interesting. Maybe you remember that. What is true about equations of lines that are perpendicular? Their slopes are flipped and negated. Slopes are, I'm going to give it a more fancy word, they're called opposite or negative. I like the word opposite because if it's negative, it becomes positive. If it's positive, it becomes negative, right? So it just becomes the opposite sign, opposite reciprocals. So this is kind of an interesting one. I'm just going to build on this. The product of slopes, product means multiplication, of perpendicular lines is always going to be what? Right? If I multiply these two together, negative 4/3 times 3/4, try that out. Do you get negative 1? Whoa, that'll always be true. That is a rule. The product of the slopes of perpendicular lines is going to be negative 1, right? So if I gave you a line that had a slope of 2/3, is there a reason I can't write? Its opposite reciprocal is negative 3/2, right? When I multiply those together, I get negative 1. If I gave you a slope of, sorry, I'm all the way up here on the right-hand corner, of negative 5, its opposite reciprocal is 1/5. Those two, the product is negative 1. So if you ever can't remember how to do the reciprocal, you can always set up a little equation and say, okay, well, what's the opposite reciprocal of 4? Well, 4x has to equal to negative 1. I get x is negative 1/4. Right? I don't want you to need that, but that's a good way to think about it. Okay? So let's think about our big idea here. Big idea here. Oh, it's hard to say. When two lines have the same slope, then the lines are parallel. Right? So we need to have it in a form where we can see the slope. It's got to be either y equals mx plus b or y equals m times x minus x1 plus y1. But I need one of these forms. If it's not in one of these forms, I need to manipulate my equation using some algebra. When the two lines have opposite, you can think of that as negative if you want, reciprocal slopes, right? So flipped, then the lines are perpendicular. Someone was wondering this, right? What if the slope and the y-intercept is the same, right? What if I give you two equations that are y equals 3x plus 4 and y equals 3x plus 4? Are these parallel? No, they're the same line, right? They're not considered parallel, so make sure you're looking at the entirety of the equation, right? We want them to have the same slope, but maybe a different y-intercept. If they have the same y-intercept as the same line, and that is what we call coinciding, right? They coincide with each other. One lays on top of the other. That's a good word, coinciding. Okay? Okay, let's do some practice. Maybe these are some good times to pause. So are lines parallel, perpendicular, or neither? Show why. Write it, rewrite it in a form that we can work with. Right? I don't know the slope of this. It's not in one of the two forms that we talked about. So let's do some rearranging. I'm going to go ahead and add 2/3 x to both sides, and that'll get me y by itself. Y equals 2/3 x minus 8. Well, this is already in the right form, so let's take a look at their slopes. 2/3 and 2/3. Let's just double check. Okay. My y-intercepts are not the same. They have the same slope, but a different y-intercept. So lines A and B are parallel. A is parallel to B. Okay, so I'm in a good form here. I've got 4 and 1/4. Okay, those are reciprocals. They're not opposite reciprocals, right? If I multiply them, I get +1, right? No, that's not good, right? So these lines will intersect, but they're neither. They're neither parallel nor perpendicular, just intersecting. Some higher level math eventually will help you to be able to actually figure out an angle between them. You'll do that eventually. Okay, so here, I don't know the slope yet, but let me go ahead and isolate the y. So that means I need to divide by 5, right? The inverse operation. So let's divide everything by 5. Don't leave anything out. Y equals negative. Nope, that's not negative, is it? 2/5 x minus 8/5. There's my slope. This is in a good form. There's my slope. So I've got 2/5 and -5/2. It's been flipped, and then it's the opposite sign. Let's just check it with that algebra. It's -10/10, which is -1. Perfect, right? So like lines E is perpendicular to line F, right? So those are my answers, right? The slopes are opposite reciprocals. Awesome. Okay, so use the graphs to determine if the lines are parallel, perpendicular, or neither. Then write the equation of the lines in either slope-intercept form or point-slope form. Now it's your choice. Okay, so let's see what we got. Let's find the slope of line 1. Here's line 1. So you're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 1, 2, 3. -9/3 means I have a slope of -3. Line 2, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And over 1, 2. Oh. Right? I thought when I looked at them, they look kind of parallel, but they aren't, right? -3 and -7/3, right? Their slopes are close. This is -3.5, but it's not parallel. Okay, so don't go by what it looks like. Find those slopes. So the equation of line 1, I'm gonna choose to do it in point slope because I don't see the y-intercept. I don't want to assume that that's it. Oh, I guess I could, but I don't know this one. Nah, I'm just gonna go with, I'll use this point. Y equals to, my slope is -3, x minus -1, so that's +1, plus 5. Okay. The equation of line 2, y equals, I'll use this line, this point. We already have the slope is -7/2, x minus -1, so +1 minus 4. Okay. What about the second one? Let's find the slope of line 1. It goes down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. That's -3/2. And then the slope of line 2, I go up 1, 2, 3, 4, 5, 6, +6. And over 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 2/3. Negative 3/2 and 2/3. Well, it's flipped and it's negated, right? And I can always check it using my rule. Right, that's negative 6 over negative 6 over positive 6, which is negative 1. Right, so these are perpendicular lines. So let's write the equation of line 1. You see how I see this y-intercept? Let's just use it. Y equals to m negative 3/2 x minus 4. For line 2, I'm going to write it in slope-intercept form. I'm sorry, point-slope form. So that's y equals to m, which is 2/3, x minus negative 5, so plus 5 minus 3. Okay, so it's using the graphs. And that was the equations and the graphs. And then finally, let's use the graph below to write the equations of the lines in point slope and slope intercept form. So I'm going to start off and I'm going to write the equation of line AB. Okay, I've got a lot of points here. It doesn't matter what pair I want to pick. I like to pick one gap between them then. So I want the slope. See how I see the y-intercept? That's super exciting. So 1, 2, 3, 1, 2. So y equals 3 over 2x. What is this? 1, 2, 3, plus 3. Right? That's a nice one to be able to do that. I could also have picked any point. Like maybe I want to pick point B. What is that? 2, 1, 2, 3, 4, 5, 6. 2, 6, just to get the practice here. Y equals to, my slope is still the same, x minus 2 plus 6. If I were to expand this, I'm going to get this. I should, okay? So now it says draw a line that passes through point C and is parallel to AB. Well, if it's parallel, we know it has the same slope. Okay, well, the slope is 3/2. Let's go from here and go up 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. I can even do this. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. Right? Oh, it's a little wonky looking, but that's okay. Okay, so I'll go ahead and say, let's see, y equals 3/2. X, what is point C? It's 1, 2, 3, negative 2. Let's use point C. X minus 3 minus 2. Let's say I want to get it into slope-intercept form. Let's distribute that 3/2. Y equals 3/2 x minus 9/2 minus 2. Let's think through this. You can use a calculator, but let's think through this. Negative 9/2 minus 2, so minus 4/2 is negative 13/2. Y equals 3/2 x minus 13/2. Sure, you can write a decimal. Fractions are better, right? Like, let's think about, I'm going to Honors Algebra 2 next year. What are some things I need to start thinking about that my Honors Algebra 2 teacher is going to want me to be able to do? Okay, so don't avoid it. Keep practicing it. Okay, last one. Let's now draw a line, a second line that passes through C that is perpendicular to AB. Perpendicular, so opposite reciprocal. Slope. So the slope is going to be, the perpendicular slope is going to be negative 2/3. So from point C, I'm going to go down 2 and to the right 1, 2, 3. Down 2 and to the right 1, 2, 3. Or up 2 and to the left 1, 2, 3. Ooh. Okay. This would probably be a little bit easier on paper with a straight line tool of some sort. That's okay. Okay. So I can see the y-intercept. That's great. It's just 0. So it's literally just y equals negative 2/3 x. I don't even need to write plus 0. And then let's write it in the other form, point slope form. Negative 2/3 x minus 3. I'm using point C minus 2. Right? If I were to distribute this, I'm going to see negative 2/3 times negative 3 is going to give me positive 2. Minus 2 is just going to give me 0. Right? Pretty cool. Okay. So in this lesson, we learned, and hopefully this is a little bit of review. We did do some of this first semester, and you might have some experience, from Algebra 1 and maybe even before. But we're now able to relate slope to determine an existing relationship between lines, as well as construct lines that must be parallel and perpendicular. So just make sure you're practicing, make sure you're doing your homework, and going ahead and using the supplemental resources. If you need to go back and rewatch anything or reach out and ask questions, please do so. Thanks everyone for watching, and we will see you soon in class.